Okay, in this problem, we're dropping a toy rocket down a well, and it's going to fall down until it reaches a point where it kicks in the rocket, and then it's going to shoot out. Okay, so what we want to know is an expression for the total height that it goes. So, the first part of the rocket's flight is where you drop it from up here, it falls down a height, h1, for a time of t1, undergoing the acceleration a1, which is just the acceleration due to gravity, and at this point it's going at velocity v1. The rocket kicks in and it shoots up and out. So this travels a distance h2 in time t2 at acceleration a2. So what we want to do is find the total height h. So we can see by this, height h is always going to be the height traveled h2 minus the height dropped h1. H equals h2 minus h1. Okay? Now the next thing we want to do is we want to find an expression for each h2 and h1 so that we can plug into h. Okay? So if you look, h2, well, that's going to be what happens here. So we have height h2, and we can use the formula v equals vt plus 1/2 at squared. h2 equals velocity initial, which is 1, v1t, v1 t2, because that's the time it travels on its portion, plus 1/2 acceleration 2, t2 squared. Alright, let's get an expression for the height 1 now. Height 1, the distance that that rocket drops, is equal to its initial velocity, which is 0. So the initial vt term we don't need, we just need the 1/2 at squared. It's 1/2 a1 t1 squared. Okay? So now we have an expression for h2 and we have an expression for h1. So what we have to do is now we want an answer in terms of only acceleration and time. And we still have, if you look at this, we almost have that, except we have v1. We just have to figure what v1 is in terms of a and t. So v1, we know we're just dropping it here and dropping it down. There's only acceleration acting on it. v1 is equal to v0 plus a1 t1. v0 is 0. So v1 is just equal to a1 t1. So now we can plug this back into h2, giving us h2 equals a1 t1 t2. So I just took this v1 and subbed in a1 t1 to give me a1 t1 t2 plus 1/2 a2 t2 squared. Alright, now I have an expression for h1 and an expression for h2. I'm just going to plug it into my height formula. H equals h2, which is this, a1 t1 t2 plus 1/2 a2 t2 squared, and I subtract off h1 minus 1/2 a1 t1 squared. So this is my formula that relates the height that this travels to the accelerations and the times.